Um, this example sheet is on one sample confidence intervals. So the only formulas you need to use are the ones in this sheet here. So these are the formulas you need to use for the first one is the confidence interval for population mean, and the population variance is known. The second one for the population mean when the population variance is unknown. The third one is for the population variance. And the last one is for the population proportion. So you need to use one of these four formulas for each of the questions in this example sheet number 9. Number 9, yes. All right. So let's start with question 1. Question 1 is this one. Just think about which formula you can use. If I ask you to derive it, then you should. But if the question is like application, then it's okay to call it. It's okay to plot and work it out. But if I ask you, I may ask you to first derive the confidence interval and then use it. In that case, you need to show the derivation. Yeah, but if the question is like question 1, for example, then you can just simply use it without proving. Yeah. Yeah. And you don't need to derive it on my unless I ask you to derive it. You don't need to do it. Yes. See that okay? Okay, guys, I'll give you like, what's the time now? I'll give you like a couple of more minutes maybe to do question 1, and after that I'll show you how to do it, right? The question 1 is pretty straightforward, guys. You shouldn't find it difficult. right, guys. So let's start with question 1. So the first thing to do is to write down everything that's given to you. You're told that n is 81. The sample mean is 11 point. Sorry. The sample mean is 74.6. The sample standard deviation is 11.3, and we are looking for a 90% confidence interval. So that means 100 times 1 minus alpha is 90. So alpha is 0.1. Okay. Now, of the 4 confidence interval, we are looking for a population mean for the confidence interval for the population mean, and we are not told what the population variance is. So the formula that we need to use is this one here, right? Because the question does not say what the population variance is. So we have to assume that the population variance is unknown. All right, so this is the formula we're going to use, right? So it's going to be x bar plus or minus s divided by square root of n, and the percentile of the t distribution. I talked about the percentile of the t in one of the earlier videos. I don't know, maybe some of you did not look at the video. This is the percentile of a t distribution with n minus 1 degree of freedom, and the probability 1 minus alpha by 2. So this becomes x bar is 74.6 plus or minus s is 11.3, square root of n is 81, right, times t, n minus 1 is 80, 1 minus alpha by 2 is 0.95. Right, now, one property I mentioned earlier in one of the review sessions a long time ago is that the t random variable approaches the standard normal variable as the degree of freedom approaches infinity. Now, in statistics, anything above 25 we can consider as large. 80 is a pretty large number. It's certainly greater than 25. So in that case, you can approximate this guy here. You can approximate the percentile of the t by the percentile of the standard normal, right? So that's what I'm going to do in the next step. I'm approximating the reason for this approximation is because the degree of freedom, which is 80, is a large number, certainly larger than 25. Anything above 25 is considered large in statistics, right? Now this you can read easily from the table for the normal, and if you read it, it will be if you read this off the table for the normal distribution, you will get 1.645. Right? So the confidence interval for the mean score, the lower limit will be 72.53, the upper limit will be 76.67. All right? So that completes question 1. Is that okay with all of you or not? Any questions, please? Are you sure? All of you okay? Yeah? Can you do question 2, please, now? Question 2, which is this one. So once again, you need to think about which formula to use, right? So there are 2 parts. Let's do the first part first, right?
table. Not always, but sometimes it's easy to read the Z table and the T table. So if you put it somewhere, you can go into the Z table. Just to see something. But it's okay, it's also okay to use this one. You get similar answers. You get similar answers. Okay. Yeah, just a minute. All right, guys, so this is the Z table. I went through this long time ago in one of the videos. This is the Z table and this is the T table, right? So this is the T table. And in the question 1, which I did just now, I could have used 80 as a degree of freedom. There's a number called 80 here. So I could have read 0.95 and got 1.664. So I could have used this number too. Instead of 1.645, I could have used 1.664, right? And got similar. Well, the numbers will not be too different, right? You know what I'm saying? Yeah. All right. Now, can you try to do question 2, please? Okay, this is the Z table and this is the T table. All right. You will get a copy of this in the exams, so don't worry. You need to know how to read them. That's it. Okay. Guys, have you done question 2 yet? If you can find it in T table, it's better to use T table. Yeah, if you can't find it in T table, then it will work. Alright guys. Hello guys, have you done question 2 yet or not? Okay, let's see how we can do the first part and then thereafter the second part. So question 2, you have n equal to 30. For the first part, you are given sigma squared as being 32, right? And you are told that the sum of xi, I from 1 to 30 is...
Sir?
Yes. Oh, sorry. Sorry guys, sorry. Thank you for being stupid today. Okay. The sum of the data is 1568.45. Right? So what that means is that x bar, remember x bar is the average. So in other words, it's 1 over 30 times 1568.45. So this is your x bar, and if you work this out, you will get this equal to 52.2817. Right? This is all we need to do the confidence interval. Now we are assuming that the population variance is known, right? So the confidence interval to use is number 1, right? This is the confidence interval to use. So I'm going to say the confidence interval is x bar plus or minus sigma by root of n z or z 1 minus alpha by 2, right? So this is going to be 52.2817 plus or minus sigma is square root of 30, n is also 30 times z. We are looking for what? 95%, all right? So that means this would be 0.975. Okay. So this will be, if you read this off the table for the normal, which I just showed you, if you read this off the table for the normal distribution, right, this guy here will become 1.96, right? So the final answer, the lower limit will be 50.32, the upper limit is 54.24. Right, so this is the 95% confidence interval, okay, for the population mean, assuming that the population variance is known, right? All right, guys, any questions? All right, now let's go to the second part. The second part, Q2. Now, the first thing, we want to find confidence interval for mu and sigma squared, assuming both are unknown. So let's start with the confidence interval for mu first, right? So the formula that we need to use is the second formula on this sheet here, this one here, right? So it's going to be x bar plus or minus s divided by square root of n. Remember, s is the sample standard deviation, t, m minus 1, 1 minus alpha by 2. Alright, so this is going to be x bar, which we already know what it is. X bar is 52.2817. I will come to s in a minute. S divided by square root of n. T, n minus 1 is 29, 0.975. Okay. All right, S, remember S is the sample standard deviation. Now, let me put a box here. S squared is defined as, this is the definition of S squared. Remember, this is the definition of sample variance. Now, another way of writing S squared, which I proved in the class some time ago, I don't know whether you recall or not, but if you have a good memory, not like me, but if you have a good memory, but you will remember this result here, that an alternative formula for S squared is this one here. These two actually equal, right? Now, if you sub in the numbers, n is 30. This guy here is given in the question as 83006.73, right? That's this minus n is 30, x bar is 52.2817 squared. Okay? You see what I've done? I have substituted for this number, right, sum of xi squared, substituted for n, and substituted for x bar. So I get this guy here. Now if you simplify this, guys, using your calculator, this will be 34.67. Right, that's your S squared. Right, now getting back to the confidence interval, this will be 52.2817 plus or minus S is going to be the square root of this guy here divided by the square root of 30. Now if you read this off the table, I mean you can read this, you can read 29 of the table, like of the T table, which 29 is not in this, actually 29 is not here, so what you can do is you can read the closest, which is 30, right? 30 is the closest number to 29, so you can read 30 and 0.975, that will give you 2.042, right? So this is what you will get. Or you can read the Z value, because 29 is a number greater than 25, you can read the Z value using the Z table here, right? But in this case, I will stick to this guy here. I will stick to 2.042, right? So this is approximately approximately 2.042, right? All right. Now, if you simplify this, you will get the lower limit to be this, and the upper limit to be this. All right. Are you guys okay with this or not? Your answer? Are you okay with this? You okay or not? Yeah. Okay. Good. Yeah. Good. All right. So that's the confidence interval for mu, and the confidence interval for sigma squared. Let's go back to the formula sheet. The formula sheet says the confidence interval for the variance is given by this expression here, right? Okay. So let's go here on the paper. So this is question 2, still part 2. The confidence interval for sigma squared, right, is Right. Okay. Now, what do you know about this guy here, guys? Let me ask you, what do you know about this? Is it related to the samples? I just talked about it just a second ago, right? Do you remember this equation? This equation here? That s squared is 1 over n minus 1 times this, right? So this guy here is n minus 1 times s squared, right? So what you have is n minus 1 times s squared in the top. Okay. Now let's sub in the numbers. N is 30, so it's 29 multiplied by s squared is 34.67 divided by chi squared 29 degree of freedom 0.975. The same thing here. Right? Okay, you can read these two guys here. You can read this guy and you can read this guy from the table for the chi-squared. Let me show you one more time. If you don't know where it is, I will show you. This is the table for the chi-squared distribution. So to read, there is 29 degree of freedom here. This is the 29 degree of freedom. So you read it along this row, right? You follow me. So you read for 0.025, which is the third column, and you also read for 0.975, which is the fifth column. Sixth column, number 6, right? Okay. So if you do that, guys, you will get the following. You will get 29 times 34.67. This guy here will become you alright, guys? And this is what you will get, and you should simplify the numbers. The lower limit is 21.99, the upper limit is 62.66. Alright, so this completes question 2. Any questions, guys? Anything not clear, please give a shout. Anyone? Come on, guys, talk to me. Are you okay? When you do the next question, it's question 3. Yes. You go to week 2, and you go to week 2, I'll show you. Week 2, and you go to the bottom. And you guys do question 3, please. Question 3. You good? Okay. There you go. All right. You guys okay? Yes, ma'am. Yes, give me a sec. Yes. Unless I ask you to derive them, then you should be able to derive them if I ask you to do so. But if a question is like, say, question 1 or question 2, then you can derive the use them. Yes. anything and write, do anything and write myself. If I ask you to derive, say for example, if I ask you to prove this, then you should get to prove this. Right, guys, can you do question 3, please? Question 3. So let me put question 3. So this is question number 3, right? Question number 3 is this one. So you need to, for question number 3, you need to use the formula. It's talking about proportions. So the formula that you need to use is this one here. So this is the confidence interval for the proportions, population proportion. So this is the one you need to use to do question number 3. Okay?
Yeah, there's an approximation. Explain what actually X bar means the sample proportion. Sample proportion.
So we're assuming that the distribution proportion is equal to the sample proportion.
Yeah. So basically, I'm using the strong large numbers. Yeah, this is what I. So assuming that the population proportion is approximately equal to the sample proportion. Yeah.
And then if we do, but we don't know the population proportion, that's why we have to use this.
Yeah, that's right.
And we're approximating the unknown distribution
Yeah,
proportion.
because to find confidence interval, we can't have it in terms of P, because P is unknown.
Yeah,
So
we're approximating.
Yeah, approximating. So you're approximating P by X bar sample proportion. So once again, for this approximation, we need to use the N. N is the sample size we need to use this one. Right, this question, I think N is pretty large, right? It's 500. So you can also approximate the products.
All right, guys, have you done question 3 yet? Let's see. So let's see how we can do question number 3. So the formula to use, I have already told you what formula to use. So let's write down what is given to us, okay, first of all. So we are told that, okay, we are told that n is 500. X bar denotes the sample proportion. In this, X bar usually denotes the sample mean, but in this for questions on proportions, X bar denotes the sample proportion. So in other words, in this case, how many people, or what's the proportion of the people that have 3 or more televisions? So which is 50 or 80 out of 500, which is 0.16. And we are looking for 90% confidence interval, which is, you guys okay? We are looking for 90% confidence interval, which is this. So alpha is 0.1. Yeah. So using the you listen, please. So using the formula that I just showed you, the confidence interval is going to be X bar plus or minus yeah. All right, guys. Now, so if you work it out, you can read this off the table for the normal. If you read it off the table for the normal, this will be 1.645, right? So simplifying, you will see the lower limit is this, the upper limit is this. All right. So what this means is that the 90% confidence, the proportion of people who have 3 or more televisions is between 0.133 and 0.187. Okay. All right, guys. You okay? Okay. Can you do the next question, please? Question 4. How many in the population of the sample have 3
Alright guys, can you do question 4 please? Question 4.
Yeah, so it's halfway between these two. So it's 1.645. That's how you get it. You can, but the thing is, you see, 0.95 is exactly half. So you can take the average of 0.05. Where else is it? Okay, I'll show you in a minute. Alright guys, had you done question 4 yet? Let's look at the first part, which is trying to look at it. Yeah, here we are. Alright. So question 4 is about, we are assuming that the population variance is none, right? So we are assuming, so in that case, if the population variance is none, then the confidence interval for the mean is this one, right? Yes? Okay, so that's what I'm going to use. So the confidence interval, question 4, the confidence interval is from x bar plus or minus sigma by root of n times z 1 minus of by 2. So this is the confidence interval, right? Now the question here is to find the width of the confidence interval. You know what width is? Width is basically the width of the confidence interval is basically the upper limit minus the lower limit, right? So in this case, the upper limit is what? The upper limit of the confidence interval is this, right? And the lower limit is this, right? Right, now if you take the difference, these two guys will cancel. So this will become 2. Right, now the question is asking you which variable quantities affect this width, right? Right, now to answer that question, there are three variables here. There's alpha, there is sigma, and there is n. Right? Now, let me ask you, if I increase the value of alpha, what will happen to this? Suppose I decide to increase the value for alpha. What do you think will happen to this, the value of this? Any answers, guys? You done your math, right? I mean, if I increase the value for alpha, right? 1 minus alpha by 2, well, what will happen to 1 minus alpha by 2? It will decrease. And so is this value. So the width as a function of alpha will decrease. Okay? Alright? And if I decide to increase the value for sigma, what will happen to the width? The sigma is in the top. So if you increase the value for sigma, the width will increase. Right? And if I decide to increase the value for n is in the bottom. Right? So the width will decrease. All right, so that's what the question is asking you for. It's asking you like how the three factors, the alpha, the sigma, and the n, how do they affect the width of the confidence interval? So the answer is this: the width increases with increasing alpha, decreases with increasing alpha, increases with increasing sigma, and decreases with increasing n. Right? All right. And the next part. Oh, we run out of time. Sorry. All right. The next part is trivial. It's just asking you to tabulate the values for the width for different values for n and different values for alpha. I'm sure I can't do it because I don't have a calculator, but I'm sure you do have. So you can do it when you have time, right? All right, guys. So the full solutions to this example sheet, as usual, you see the typed solution, the handwritten solution, and the video solution. So all three solutions are on the course website. So please have a look. See you.
Yes, for the locals and why the sample proportion is equal to x bar.
X bar is simply X bar usually means sample mean, right? But in the questions on proportion, X bar means sample proportion. It has a different meaning. When you have a question on proportions, X bar is sample proportion.
Oh, okay.
Okay.
It's same meaning.
Same meaning, yeah. Same meaning, yeah.
Thank you.
Yes, sir.
我的 proportion 是x bar 是对，如果我在那个
Maybe, I don't know. Maybe I have to check it.
就它是一个一个。
Because
r equals to
yeah, it should be 2. Yeah, it should be 2. Yeah, that's a mistake. Sorry. Thank you for pointing out. Yeah.
1.